Hey guys, hopefully this comes through pretty well. Um, we're gonna try out something new, and we're gonna do some brief review of the topics that we've covered so far this semester uh, in a video format. And so we're gonna try to do these each week. My name's John Moosemiller, as you can see. I'm one of the TAs. I've been TAing for quite a while now. Anyways, the topics we're going to be covering today are variables and their naming conventions, the different types of data that you can have, how you load in data, fprintf, and user inputs. So going through one by one, we'll try to make our way through this. So this is going to be review 1. And our first topic we said was going to be variables. So variables obviously are what you're going to be dealing with most often in MATLAB. And so we want to make sure that you guys are adhering to some of the common practices, because there's a reason why they're common practices. So for example, one of those things is we always, and this is all just the naming of variables. We always start variables with a capital letter. Capital letter. Now, the reason that we do this is sort of twofold. One, it avoids a lot of the issues you can have with either redefining predefined variables in MATLAB, such as pi or I or j, and it also helps you avoid naming something the same as a MATLAB predefined function. So this is something that when we get towards using more functions later in the semester, is going to be much more prevalent, and you're going to have to be a little more careful about. But if you capitalize all of your variables, you'll never have to worry about that, because all of MATLAB's inbuilt stuff, all their internal functions start with a lowercase letter. Now, there are a few other rules. For example, you can't start with a character that isn't a letter. So you can't start a variable without a letter. So for example, underscore John would be no good, right? But if we had J underscore OHN, this would be A-OK. So just keep that in mind as you're going through. Now, a couple other things just for making your TAs like you, or rather at least not hate you. It's really nice when you're clear about what the variable actually contains. So we'll talk later in the semester about how to make comments in your code and how that helps us when we're grading. But we really want to, the easier you make it for us to grade, the easier it's going to be for you to get as many points as you can. So just try to be as clear as possible. So that's like if you're creating a function that calculates the volume of a sphere, you don't want to call the volume like green, right? Like green doesn't mean anything. Or you wouldn't want to call the volume height or length. If you're like doing anything like that, you would want to call it volume or some form of that word, or vol or v, or just something that indicates sort of what that is. So the more clear you can be, the better. It also helps if you're concise. That way you just reduce the number of typing errors that you can have. But that's sort of a personal thing. So that's about it for variable names. The only other thing I'll say is when you're in MATLAB, just remember that you have to have, if you're assigning to a variable, the format is the variable name, the variable, and then equals A, or 15, or whatever. So when you're doing it, the variable is on the left-hand side, and what you're assigning to that variable is on the right-hand side of the equal. So if I want to assign, I'll get rid of the A because it's a little confusing, but if I want to assign 15 to the variable called variable, then this is how I would format it. So just be careful. You can't assign things on the left-hand side of an equal to the right-hand side of an equal. So yeah, I think that about covers it for variables. So I'm going to go ahead and move on to data types. So I'm just going to talk briefly about the data types that we covered in class this week. So as I go through, make sure that you guys know what each of these data types is, what kind of functions you'll use for it. So I'm actually going to make a little table here. So I'm going to have data type in one column, and in the other column I'm going to have the function to load that data type. So first things first, we'll start off with the easy stuff. So if you have a .csv file, now if you've been using if you've been using things like Excel or other programs like that for a while, you'll probably have seen a .csv file before. What CSV stands for is comma separated value. So I'll just make a note of that here, comma separated value. And so the functions that we can use to load it, there are a few. So you can actually, I just tested this out, and this is certainly not the recommended one, but you can use XLS read. Though again, you probably shouldn't. Don't use this. It's really, really slow. That's why I say don't use it, because it's not meant for CSV files. There are some others. There's CSV read. Now this is the one I would recommend. It's the easiest because it's designed specifically for comma separated value files. Finally, or there are a few others. DLM read is the other one of note. And so DLM read is sort of going to be our transition, because what DLM stands for is delimited. So this is delimited read. Whoa. And so what this means is that this can read in any file type that has a constant separator. So if we move along, one of those constant separators is spaces, or some of the common ones are spaces, tabs, and new lines. And so if we have a .txt file, what you really have to do is open it in Notepad or whatever your sort of base model processor, word processor is, because that way you'll be able to tell how the data is separated. Now, if it's separated by commas and it's a .txt, you can actually use CSV read to load that data in, but you might just want to use something like DLM read. And then the only note is with DLM read, one of the inputs is actually, one of the inputs to the function is the delimiter that you have. So for space delimited files, you would have something like A equals DLM read, open parenthesis, single quote, right? And then you would say, so this would be my data.txt. And so I said it's space delimited. So I'd close that out, have my comma, and then have a space here. So I can't obviously draw a space because then it'll look like an underscore. But you can put anything here, and that is what it will use to delimit the file and delineate or check what values are where. But this is how you format it with a space here. So this is a space. So I'm going to also upload these documents. This sheet I'm going to turn into a PDF or whatever, so you don't have to worry about it. Now, like I said, you can also use CSV read if it's comma separated and the file type is, and the file extension is just .txt. Moving on, what if you have .xls or .xlsx? For these, what you're going to do is you're going to use XLS read. And before I go any further, there are almost always equivalent functions to all of these for writing. So there's XLS read, there's also XLS write. There's DLM read, there's DLM write. There's CSV read, there's CSV write. So just keep that in mind. So XLS read is used for Excel files. For Excel files. And the other thing is it's tricky on Macs. So you just have to be a little careful. There's a lot of stuff on the MATLAB forums about it if you're having trouble with it, but it really isn't too much different than the ones that we've already gone over. The one note that it gets tacked onto that is this can handle multiple types of data. And so what I mean by that is this can handle having text or having strings in the first column, having numeric values in the second column, and then having more strings in the third column. And it's able to handle that. You have to treat it a little special, and the way that you call the function's a little different. But if you look at the documentation in MATLAB, it's pretty clear, and hopefully that can get you through it. This is going to be helpful in your NEE projects when you're loading in data. So you can also select from different parts of the document and everything like that, and that's not too bad. Now, if you have .jpg, .png, there's also .jpeg, and I'm sure it's able to handle other image types, although I haven't checked in a while. I would guess it handles like TIFF and things like that, but I would just use these because these are the most common. For these, you're going to use imread. So when we do imaging later in the semester, this is the function you'll use. And this is for images. Now, I know all the professors probably went over this in class. Really make sure that you suppress the output for when you're loading these in. Otherwise, you can hit Control-C on both Macs and PCs, and it will cancel whatever command you're currently running. And so if you start seeing just walls and walls and walls of variables, then, then that's when you know you messed up, and you can just hit Control-C, hit up, put in the semicolon, and actually run it. So that's about it for the different data types that we normally use. So now I'm going to talk briefly about the different types of variables. So I guess I'll make this a dark line. So then this is just going to be type. And this is going to be sort of my explanation. And so I might just make a list here now that I'm thinking about it. I'll write explanation, but so there's several types in MATLAB. Some of the notable ones are you have integers. Oh, let me switch integers. And so let me open MATLAB really quick. And what I will do is I will show you, assuming it opens in a reasonable amount of time, where you're going to be able to find this information. So there's the int type, which is integers. So this is your 1, 2, 3, -6, those kind of things. You have what are called unsigned integer. So with this is 8, sometimes you'll see 16, sometimes 32, and I think 64 as well, though again, I haven't checked lately. This stands for unsigned integers. Unsigned integer. And so you can just treat these as numbers. So in MATLAB, if I type, oh, let me actually share my desktop. Share screen. Is MATLAB gonna finish loading? I guess not, at least not yet. So we'll wait for it. Then we also have strings. So we have strings, and these are, I should actually sort of switch this, I think, just to be more accurate. Strings would be the explanation, and the data type would be a character array. So this, I guess your example of this would be if you said A equals, and then you have your single parenthesis, hello, John, and then single parenthesis, right? So that whole string would be it would show up as a 1. The dimensions of this would be, so dimensions, right? The dimensions of this would be a 1 row, right? Because we don't have multiple rows in this. A 1 row, 1, 2, 3, 4, 5, 6 because of the space, 7, 8, 9, 10. So this is 1 by 10 char is what it would show in MATLAB. So if I go ahead and do this and I say A, let me find my equal. Do I have it here? No, I don't. So A equals, and then our single quote, which I'm hoping to find somewhere. So A equals, well, whatever. This shows up here, and if I hover over this, I don't know if it'll show. It says 1x4 car. I don't know if it showed before you could. I don't know if you could see that before it quit out, but if you hover over this, it will show you. It'll tell you what type of variable it is. So you see the CH, that stands for character. So yeah, now it's showing the 1x4 character. There. Now, we also have things called string arrays. And so, let me go here. So then we have string arrays. And so these are built in sort of a similar way, although not super similar. So let's build one together real quick. We'll say b equals. And then for this, what we need to use is brackets and, excuse me, full quotes, all right? So I might say hello in one, and then I'll have a space, and that delineates, right? Because we know when we're creating vectors, which is what this is, spaces delineate. And so then I can say John, and put that in, and close our brackets out. And you can see I get a string array. Now this is a 1x2 string array. So each one of these individual things is a string. So this is a string, and this is a string. They can be treated as strings once you pull that data out of the string array. So once I reference B1, so I can hopefully do that quickly, B1, then you can see I get a string that's B1. So this will be helpful. This is sort of a set of strings. I think that's the best way to describe this, or describe a string array. For both of these, I should just point out, these can be, they can be both, they can be, it's not a both if there's three things. They can be single values. So this would be like values. This would be like A equals 15, right? They can be vectors. Now vectors would be something like A equals 1, 2, 3, or they can be arrays. And this would be something like A equals 1, 2, semicolon, 3, 5. So they can be 1, 2, even 3-dimensional arrays. So that's just something to keep in mind. Now, if you load in images, they're going to load in as some type of number. Just be careful about that. There's also another type that I don't think they've talked about in class, but will become important later in the semester, so I'll just cover it. There's called logicals. And then, so this is ones or zeros. That's it. 1 meaning true, 0 meaning false. So again, don't worry about this yet, just sort of a little bit of prep. I think that's all there is for the actual types in MATLAB. Let me check my notes, but yeah, I think that's most of what you're going to be covering. So a couple more things. We wanted to cover fprintf and user inputs. So let us go on to fprintf. So fprintf, first just a little bit of talking, and this is probably repeated from your lecture, but I'll do it anyways. This is going to be used time and again. It's used to display data. I know the name is a little weird. It's not print, it's fprint, which actually stands for file print. And so the file that it is printing to is your command window, and that doesn't quite make sense, but I promise it does if you really think about it and sort of know the history of where that name's coming from. So this is used to display data, whatever that type of data is, used to display data in the command window. Command window. So, how does it work? So, if you just wanted to print a string, that would be very easy, right? So your basic example would be fprintf, and then you would say something like, hello, world. This is a closed bracket, or a closed parenthesis. Close apostrophe, or it's just an apostrophe. So hello world, and you'd be good to go. You could put this in the command window, and it would pop up, and it would just say hello world. Now, there's certainly more versatile things you can do with it. So if I define a variable a, and I say a is equal to 15, and then I have fprintf, and I say hello, and then I have a space here, percent, what would it be? Let's see, for percent f, for the f stands for floating point number. So percent f 0.0, right? Because I'm saying I don't need any decimal points. That's what this says. The 0 is how many places you want before the decimal. Or it might be something else. Don't quote me on that. But so 0.0, and then world. And then before I close out my parenthesis, what I did is I said A. Then this would display, and I'll put this actually, I'll make it look like MATLAB and draw it in green. So this would display as hello 15 world. So it would actually put in the value that was stored in A into this string that it's printing to our command window. So you can do this with a bunch of things. So the more variables you have here, the more variables you have, this means the more inputs that you have. So if you had a bunch of %fs, or there's also things like %s, and if you go on to the fprintf documentation, which I highly suggest you do for any function when you're looking at it for the first time, go to the MATLAB documentation. There's a list of all the different things that it can do. So I'll go ahead and do that right now. So if I search the documentation here for fprintf, it will pop up this very useful help menu that has examples with it. You can see here that we have a string, right? So this is a string that's been made. We have two variables here with A1 and A2, and then we have two variables in this previous line as well. So it's important that those numbers match up. If they don't, you're not actually going to get an error. It's just going to look really weird. So if you are working on a project and you don't get an error, but your numbers seem weird, or it's printing things in a weird way and it just doesn't quite seem right, make sure that you have the same number of inputs as you have variables that MATLAB is looking for. So each time it sees a percent, it's going to be looking for a variable. So that's how you know. So 2 percentage signs here, that means it's looking for two variables, and we have those. You can see there are a ton of examples, and down here we have the sort of the key to each type. So if you know it's an integer, you can use D or I. If you know it's a floating point number, you can use F, E if you want the exponential notation. I guess capital E if you need the capital E in the notation. That's kind of funny. But yeah, so as you go down, you can see the different things. And so looking in the documentation for any function is super, super helpful. So you'll always see stuff that you might not always use immediately, but read through it anyways, see how it works, and you might end up using it eventually. So yeah, just be mindful of that. And you can mix and match too. So if you have strings that you want to put into other strings, can you do it like this? Things like that. What else is in my note? User inputs. So if I go up here and I say, give me inputs. Let me put the T in again. So we can see how input works. And so what I'm going to do briefly, and this is just, again, going to show you how to use the documentation effectively. So this is input. This is the most basic one. You'll use it a lot. It works for a variety of types. You can force it to turn things into a string or request a string. You can have it input whole vectors or arrays even. It's very versatile. But if you scroll all the way to the bottom, you always get a window like this. And if I can draw quickly this. So always look at the CLSO functions. You can sort of go down a rabbit hole eventually with it, but a lot of these functions you'll either have to use or you might want to use later in the semester. So in particular, menu is a really good one, and we will use that. There's input dialog, input DLG. There's G-input, which asks you for a graphical input, and it has you click on a graph. So if you're trying to locate something on a graph, maybe you want to do G-input, things like that. If you're actually looking for, let me stop annotating. If you're looking for more information on any of these functions, always, always, always look into the documentation. So it's very simple. On the left-hand side of the equal, you have the variable that you want to assign the input to. On the right-hand side, you have your input, and then you put a prompt inside. And that prompt has to be a string, and that's about it. you can see they have examples of both usage cases. And so again, I would just very much recommend you go and actually test this out and try it out yourself. Make sure that you're comfortable with it. With all that being said, I think this has gone long enough. I'll put timestamps in each of these videos, hopefully to give you a better idea of everything, where everything is in the videos. And again, I'll also post this review. But hopefully in the future, this one we didn't because we didn't expect a lot of questions. But in the future, we're going to be holding these on Fridays, and it's actually going to be something that you guys can join in on. And so we would really, really like to have you guys come in, ask us questions, because going through and answering questions is something that can really help us understand what students are struggling with. And at the same time, it's really going to help you because you're going to get a thorough explanation, and you'll be able to look back on that explanation in the future. And so it'll really help everyone if you stop by. So I think with that, I'm going to end this off. I really appreciate everyone who's watched this and hope it has done and served you well. If you have any comments about either things I didn't cover, ways or methods you would like me to cover things more or less, um, please let me know. And I'll try to incorporate that, and myself and the other TAs will try to incorporate that in future editions of this. Um, so